Going on, guys? We have this question right here. It's asking use cofactor method to find the inverse of a, and a is given 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2, and this is the answer we have to derive. And let's see how did they derive this. So first of all, before doing this kind of question, first of all we have to know what is the formula for inverse. There's a general formula for that. It's a inverse is equal to 1 over determinant a multiplied by cofactor A transpose. So this is the general formula. Since we have to find determinant A, cofactor A transpose, let's begin with the determinant A. So if I want to find determinant A, there's a method to find this. Let's copy this down first. So 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2, right? So in this case I had to put plus minus plus. So if it extends, if the column extends, we have to keep continuing like plus minus plus minus plus minus. So you have to keep doing this. So this is not equal to determinant. So I form the equation right here. So determinant A, I start with a 2. So if I start with a 2, I have to eliminate whatever the vertical components related to 2 and horizontal components related to 2. So if I eliminate those things, we have left with 2 minus 1 minus 1 2. So in this case I have to do AD minus BC formula. If you wonder what is AD minus BC, this is going to be that AB CD CD, this is AD, right? This is AD, this is BC, and AD minus BC is the general formula to find determinant in 2 by 2 matrices. So since we have 2 by 2 matrix right here, we can use that formula. So it's going to be 2 by 2, it's going to be 2 times 2 is going to be 4, minus 1 plus 1, so it's going to be minus 1. Then we have, so we have to keep doing this one for everything. So I have done this for 2, now for I have to do for minus 1. So when I do minus 1, I have to eliminate all the vertical components of that and horizontal components of that. If I eliminate that, I will left with 0, minus 1 0, minus 1 2, and then minus 1 mean this is minus 1 is plus 1, so I have to put plus 1 right here. Then minus 1 times 2 is going to be negative 2, and 0 times minus 1 is going to be 0, so it's just negative 2, and this is 0, so plus 0 0 multiplied by any number, it's going to be 0, so we don't even have to look at that. So it's going to be 2 times 3 is going to be 6, 6 1 time minus 2 is minus 2, so minus 2 it's going to be 4. So determinant A is 4, so this is going to be 1 over 4. That's how they got 1 over 4. So that's what we have found out. Now I have to find out cofactor A. So to find the cofactor A, there's a general method to do that. So first of all, I list what are the cofactors. So this is cofactor 1 1, cofactor 1 2, cofactor 1 3, 1 4, 1 5, so 2 1, 2 2, 2 3, 3 1, 3 2, 3 3, right? So these are the cofactors. So what is the formula to find cofactors? First of all, if it's 1 1, I saw you example for 1 1. So cofactor, if it's cofactor 1 1, what you have to do is minus 1. This is general formula, minus 1, always minus 1. And if it's 1 1, cofactor 1 1, we have to just 1, and we have to add those two numbers. So if it's 1 1, I have to add 1 1, this is the power, and then I have to find determinant of 1 1. So it's going to be the same approach. If I take 1 1, it means all the vertical components is eliminated, horizontal component is eliminated, and this is, I have to find this determinant. It's going to be same approach as determinant A, like how I find determinant, right? So this is going to be same approach. So since it's in this case, if I take 1 1, these all are eliminated, we have left with 2 minus 1 minus 1 2, 2 minus 1 minus 1 2. Then what I have to do is 2 2 is going to be 4, so 4 minus 1 is going to be 3. Since negative 1 to the power of 2, if it's 2, then it's gonna be if you square any negative number by an even number 2, 4, 6 or whatever, you will get a positive number, so it's going to be positive 3. That's, for example, if you get 3, 5, 6, 7 or any odd number, you will get a negative number. So if you get, for example, let's say this is 1, 2, right? So if it's 3, negative 1 to the power of 3 is going to be negative 1. Therefore, if you get determinant 3, you have to multiply it by negative 1, you will get negative 3. The negative 3 will be the answer. In this case, this is an even number, therefore I put 3 straightly. So when I do coefficient 1, 2, it's going to change. Now what will happen is minus 1, 1, 2, 1 plus 2, determinant. So this is going to be, this is what I'm going to take it. So if I take this one, all the vertical components removed, horizontal component removed, this is going to be the determinant I have to find. Minus 1, minus 1, 0, 2. So when I find determinant, it's minus 1 times 2 is going to be negative 2. This is 0, so it's just negative 2. Now we have to remember that when I multiply, this is going to be 3, right? Minus 1 to the power 3. So when I multiply this one by a negative number, this will become positive and become positive 2. That's how we do. So you have to do the same thing for everything. So 1, 3, and if you do the same thing, and you will get 1, and you have to then start with 2, 1, and you will get 2, and do the same thing, and you will finally end up with this number. So I would list all the number 2, 4, 2, 1, 2, 3. This is the number you are going to get. Then you have to arrange in the cofactor method. So 1, 1 means it's going to be here, 1, 2 here, here, 1, 2, 4, 1, 2, 4. Then this is 2, 4, 2, 2, 4, 2, 2, 4, 2, 1, 2, 3. Right? This is the number we are going to get. But don't forget, guys, we have a transpose right here. So we have to transpose this one. We have to transpose, but when we transpose this one, we will get the same number, because when you imagine, if you flip this one, for example, I flip the first row into vertical, it's going to be 3, 2, 1. If I flip this 2, 4, 2, if I flip this, it's 1, 2, 3. So in this case, I can keep the same number, because when I flip, I get the same number. But it doesn't work all the time. Sometimes we will get a different number. So we always have to flip it. That's the final step. And our final answer is going to be A inverse is the question. So I have to put 1 over determinant A. 1 over determinant is 4. And then I have to write this whole number 3, 2, 1, 2, 4, 2, 1, 2, 3. This is my final answer. I hope you guys like this video. See you next time.